Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining OSPF authentication for both OSPF version 2 and version 3. OSPF creates neighbor adjacencies between OSPF routers. But what happens if you get a malicious device that tries to masquerade as an OSPF router, and it forms a neighbor adjacency with a legitimate router on the topology? In this case, such a malicious device may send false LSAs with incorrect routing information. This neighbor now has the opportunity to cause havoc on the network by messing up the routing, bringing the network to a halt, or even worse, by redirecting traffic to another location. OSPF authentication is used to authenticate OSPF neighbors between them, thus ensuring that unauthorized routers cannot form an adjacency and cause harm. Now, in one of my earlier videos on OSPF, I did mention something about OSPF authentication and how it is one of the areas where OSPF version 2 and version 3 differ. OSPF version 2 uses plain text and MD5 for its authentication and is an actual native feature of OSPF version 2. In other words, authentication takes place within the OSPF messages that are exchanged between routers. OSPF version 3 doesn't natively support authentication. It takes advantage of IPv6's built-in authentication mechanisms as part of the IPsec suite. It takes place in the IP layer and not as part of OSPF messages. This provides a better overall authentication mechanism, which is much more secure. In this video, we'll take a look at both of these configurations for OSPF version 2 and version 3. Let's start with how authentication is configured in OSPF version 2. We start off with the OSPF configuration for both routers that will create the neighbor adjacency. As you can see, we are advertising this network here, the network that links the two routers together, and this makes the two OSPF routers search for potential neighbors on these interfaces. They find each other, and a neighbor adjacency is formed. Let's now configure authentication using MD5. First, we must configure it on the interfaces through which the neighbor adjacency takes place. We do that by issuing these two commands. The first command specifies the hash algorithm and the password to be used. We use IP OSPF message digest key 1 MD5. 1 is the key number, and it can really be anything as long as it's the same on both routers. You then specify the password, and I used telecomTech for that. The second command is used to ensure OSPF authentication on the interface. There's one more thing that we have to keep in mind. This command here enables OSPF authentication on a per interface basis. This can actually be replaced with a single command in the OSPF router configuration. If we issue this command at the router configuration mode, then we are saying that all interfaces on the local router with networks on area 0 have authentication enabled. If this is implemented, then we only need to apply the OSPF message digest key command on the relevant interfaces. But authentication must be configured on all neighboring OSPF routers in order for adjacencies to form. In other words, this command here in router configuration mode makes authentication mandatory for all adjacencies. Now, when you apply these commands, you'll see that the current adjacency will be torn down, and only after the full authentication configuration has been completed on both ends will you see the adjacencies come back up again. Now, to verify this, let's take a look at the output of the show IP OSPF interface command for each of these interfaces. You can see in R1 that the term message digest and the key number appear. Message digest simply means that an MD5 hash-based authentication has successfully been implemented. It's that simple. Just make sure that all of the routers in the area are configured with the authentication in their router configs, and all relevant interfaces are configured to send and authenticate OSPF adjacencies using MD5. Now let's take a look at authentication in OSPF version 3. I won't go into the details of how to configure version 3, I've done that in a previous video. I'll just say first that we have to explicitly configure a router ID in each router as I have done here. Next, we go into the interfaces themselves and configure OSPF version 3 for IPv6. Remember, we don't have to configure IPv6 addresses here. The automatically assigned IPv6 link local addresses are being used for the creation of the OSPF version 3 adjacency. Now at this point, we should have an active OSPF version 3 adjacency between these routers. Next, we get to the configuration of the authentication. This is done at the interface level, just like with OSPF version 2. We can do it with this command here. Now let me explain what's happening. First, we have the IPv6 OSPF Authentication command, followed by IPsec, which tells us that we will be using the IPsec framework for that authentication. The choice here is either null or IPsec, where null would be a plain text password, something you should never do. Next, we have SPI 500, which is the security parameter index, and we're using a value of 500. This is similar to the message digest key number in OSPF version 2, and this can be any 32-bit number starting at 256, as long as it's the same on both ends. Since 256 is the lowest number in this range, I chose to use 500. Next, we have SHA-1. This is the hash algorithm that will be used. We could have chosen MD5, but SHA-1 is more secure. Finally, we input a 40-character hexadecimal value, which is the key that will be used for authentication. That's what SHA-1 needs for its authentication process. You can use a random key generator to create that, but make sure that it is in hexadecimal, which means it uses characters ranging from 0 to 9 and A to F. Now, just to clarify, all of this is one command on a single line. I've just displayed it here like this for convenience. And that's it. Once you put in all of those options, you'll see the OSPF adjacency fail and then reestablish. Now, similar to the OSPF version 2 situation, we can obligate all OSPF version 3 neighbors to use authentication by issuing this command, area 0 authentication, in the router configuration mode. This will require that all interfaces configured in Area 0 must have authentication configured to successfully establish adjacencies with other OSPF version 3 routers. In that way, if you have a rogue router trying to establish an adjacency, your legitimate router will always ask for authentication. It won't accept any neighbors that attempt to become neighbors without authentication. Now let's take a look at the results. We can see that the authentication being used is SHA-1 with an SPI of 500 on both routers. So we're done. And that's how you configure OSPF version 2 and version 3 authentication. Well, I hope you found this video useful, and if you have, I would ask that you consider using the YouTube Super Thanks feature to say thank you and support my efforts to simply explain telecom and networking. As I'm always striving to improve my videos, the funds will be used to support better equipment, better quality, better video editing services, and just to produce more useful training content. As always, check out my website where you'll find in-depth courses with labs, quizzes, and exams to test your knowledge and prepare you for certifications as well as for the real-world networking and telecom industry. And don't forget to subscribe to the channel to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.